Hi parents and students, hope you're doing well. You got a sheet last week that week 3, or week 2 that looked like this, and week 3 you're going to get the same sheets, a little bit different items to work on. We're going to expand on that idea of taking apart numbers to work with them. Whenever we take something apart, we call it distributing. You take something apart to move it around. And in math, we call this the distributive property. Again, we're going to go from concrete, a concrete example, over to abstract. So I'm going to use an example over here in concrete that you'll be able to easily see, and then over here we're just going to use our minds to imagine it. Let's say you have 20 marbles and you have 5 friends. I'm going to represent your friends as circle. Now, to be more concrete, you would have your friends over here. I don't know your friends, so I'm just going to use circles to represent your friends. These are going to be your friends. And there's 5 of them. You're going to start handing out models or handing out marbles to each of your 5 friends. So this is a counting exercise. Each one gets 1 marble. And we're going to do that until all 20 marbles are gone, because you want them to play and you have some more marbles that's left over. But you want them to have the marbles that you've got. And you don't want them arguing, so let's see if this is going to work out. So I have 3, I'm going to use my skip counting. 3, 6, 9, 12, 15. 16, 17, 18, 19, 20. There's all my 20 marbles. Now you took 20 marbles and you distributed them amongst 5 friends. That's a property in math that's used a lot. If we were to write this as an equation, it would be 4, how many each one got, 5 times. And you can see that equals 20 as well. Now you've had work like this where in this case cubes, rods, and flats have been distributed and you're grouping them in base 10. You had an example like this in week 2 where you had the standard form and you expanded this. These are both examples of the distributive property using base 10. So we're going to look at that as how it can apply to multiplication. So let's take the number 348 to start with. And let's distribute that in base 10. Because that's our number system. We have a base 10 number system. So we'd have 300 plus 40 plus 8. Now let's say we wanted to multiply that 3 times, just like we did over here with your friends. We'd have to do this 3 times. This is the first time we did it. Okay. Let's do this another time. That's the second time we did it. Let's do it one more time. This would be 3 times. Now when we multiply over here, This can be a little confusing, so let me clear this up right away. When we multiply up here, what do we call our solution here? What's the name of that solution? If you said the product, you're correct. Since we're adding here, what do we call the solution using addition? If you said the sum is correct. So addition and multiplication are kind of related to each other. Let's go ahead and find the sum over here. We have 8, 16, 24. I'm skip counting by 8s. I have 0 plus 0 plus 0. If you don't know what that is, then I'm going to send you back to first grade. Then we have 4, 8, 12. So this number becomes 120 because it's in the tens place. We always have to add a 0 in the tens place. This number, we have a column of zeros and another column of zeros. And I'm going to skip count by 3s. 3, 6, 9. We have 9 there. So if we add all these up, it's the same as doing more complicated multiplication. So we might have to use column addition here. We call this column addition because we're adding the numbers up in columns, depending on place value. Let's add the 1s up first, that's 4. Let's add the 10s up, that's 4. And let's add the 1s up, that's 10. So our product here is 1,044. Well, it's kind of a product if we do it over here, and it's the sum if we do it over here. So this would be the sum. So now we're going to go to completely abstract. And in an abstract model, we're going to take 348 times 3, and we're going to use what was called the partial product. Method for using multiplication. And you're going to find something very similar, strikingly similar between this example here. We're still doing this in base 10. We're still distributing our standard number over the base 10. We're going to not do that here, but watch how I get to this solution over on this side. I'm going to say 3 times 8. I already did 3 times 8 here. It's 24. I'm keeping everything lined up in my 1s and my 10s place. I'm going to say, now I'm going to go over my 10s place. Now, if you remember in our 10s place, we had to put a 0 in the 1s place because there's no 1s in the 10s place. They call this a placeholder sometimes. I'm going to say 3 times 4, that's 120. 12 plus this placeholder over here makes it 120. Starting to look familiar? Now I'm going to say 3 times 3, but first, this is in the hundreds place, and I have the 1s and the 10s. In the hundreds place, we don't have any 1s, and we don't have any 10s. So I'm going to say 3 times 3 is 9. Now I'm going to add this up. This looks very similar to this over here. This one's relatively upside down to this one. I'm going to add this up. 4, 4, 10, and I get the same answer. So we've taken a multiplication problem that could normally be a little bit difficult to solve. We distributed it in this example and came up with an answer. Over here, we're using partial products. Over here, we're just going to come up with one product. Here we took the products apart by place value and then added them together. And here's we're going to call this our product. Even though we use addition at the end, we're solving a multiplication problem. This would be correct. This would be correct also, and this would be correct. This would be an easy example over here of distributive property. Here's the distributive property using base 10 and then multiplying that by 3. Here's a partial product example of using multiplication in what we usually term a standard form, but here we're separating the products by place value and doing one side at a time. Very important that everything keeps in line according to place value. Otherwise, your numbers are going to get all crazy and you won't get a right answer. Good luck with this. If you have any questions, write them in the comments on the YouTube channel or send it in your attendance sheet. Hope you enjoyed this.